So welcome everybody to this latest video on 162 Math, and in this video we'll be going over the GCSE higher topic of equations of a circle. Now as always, if you're wanting copies of the questions you can download them in the descriptions, and I'll also include some notes in there as well. Now in the early stages of maths we start to plot horizontal and vertical lines on a set of axes. So for example, looking at this first graph here, we've got our horizontal line which is represented by y equals a number, and then we have a vertical line which is represented by x equals a number, and that's one of the very early stages of plotting straight line graphs onto a set of axes. We then move on to diagonal lines, so then we start moving on to y equals mx plus c, and that's when m is positive, and we can have again y equals mx plus c, and this is where m is negative. And then we start moving on to quadratic graphs, so when we've got a positive parabola, and that's when x squared is positive, or we could have a negative parabola where we have a negative x squared. And that then moves on to more complicated graphs. So we can then move on to cubic graphs. So a cubic graph could look like this if it's got y equals x cubed. We could also have this here where we've got y equals minus x cubed. And we could also have cubic graphs that look like this, or we could have cubic graphs that look like that. So where it looks like an S shape. And then we move into reciprocal graphs. So reciprocal graphs can look like this, or they can look like this. And then we move on to exponential graphs, which can look like this, or can look like that. Now, as the latter look at curves, is it possible to plot a circle using an equation? So is there an equation that exists where if you plot it, it would make a perfect circle using x and y data? And the answer is yes. So when drawing a circle, particularly on a set of axes, you need two pieces of information. One of them is going to be the center of the circle, and the second is going to be the radius. And because obviously all circles are going to be similar shapes. Now the equation of a circle is represented by this formula here. Now this formula is the equation of a circle when you know the center and when you know the radius, and that's where we substitute our a and b values and our r values, and then you're left with equation involving x's and y's. Now this formula here, although it can be used at GCSE, is more an A level or is also a level 2 further maths equation that you're more likely to use if you're sitting either of those two exams. For GCSE, it's unlikely that you will ever need to use this particular formula, but if you do, then that is absolutely fine because it is a valid formula to use. Now at GCSE level, the center tends to always be the origin of the set of axes, which makes the equation of the circle with center 0, 0. So when the center is 0, 0, then these brackets are basically just going to be x and y respectively. So therefore then, what we've then got is this formula here, which is more the equation of a circle when the center is at the origin or at the coordinate of 0, 0. So let's now have a look at some example questions. So here, hopefully this will then make sense. So in this particular question 1, it says which of the three circles drawn on the grid represents the graph x squared plus y squared equals 4. So looking at this, what we then need to do is we've got x squared plus y squared equals r squared. Now from this we can see that because we're not adding or subtracting anything to the x or the y in this formula, then that basically in equation rather, it means that the center is 0, 0. So that there is a fact. Now looking at this, we know that r squared equals 4, so r equals 2. Now the reason why I'm not going to write plus or minus is because r represents length and you can't have negative length. So here the radius will always be the positive number. So I'm looking for a circle with center of 0, 0, where the center of the circle is at the origin with a radius of 2. So which circle here has a center of 0? Well, there's two circles. It's either going to be A or C, but has a radius of 2, and that's going to be A. Moving on to question 2, it says that a circle has the equation of x squared plus y squared equals 25. The circle passes through the points A, B, C, and D. Complete the coordinates for A, B, and C. So, taking these individually, now in this particular question here, we know that x equals 5. So what I need to do is I need to substitute x equals 5 into the equation of this circle. So here I'm going to have 5 squared plus y squared equals 25. So 25 plus y squared equals 25. So y squared equals 0. So y is therefore going to equal 0. So I put a 0 there. For the next one, again here I know that y equals minus 5. So then if I then substitute y equals minus 5 into the equation of the circle, I end up with x squared plus minus 5 squared equals 25. X squared plus 25, which is minus 5 times minus 5 is positive 25, equals 25. So x squared equals 0. So therefore x is going to equal 0. Moving on to the next one. So this is where I'm substituting y equals 0. So here I've got x squared plus y squared equals 25. So swapping y for 0, I get x squared equals 25. So x equals plus or minus 5. Now I've already used x equals positive 5 in A. So therefore x must equal minus 5 as A uses positive 5, or x equals positive 5. So then the answer I need to write here is minus 5. Then moving on to D. So this is where x equals 0. So if I substitute x equals 0 into x squared plus y squared equals 25, I end up with y squared equals 25. So y equals plus or minus 5. So I've already used y equals minus 5. So therefore y must equal positive 5 as B uses y equals minus 5. And there I've completed my coordinates. Moving on to question 3, it says describe fully the graph which has the equation of x squared plus y squared equals 9. So a couple of points we need to note here is that we're going to have a circle. It's going to have a center at the origin because there is nothing being added or subtracted to the y's, and the radius is going to equal the square root of 9. And it's important that you remember it's the square root of 9, which can be simplified as being 3. So I would make sure that when you're describing the graph, you represent those three things. So one, it's a circle, where the center is, and what the radius is. Moving on to question 4, it says that the circle shown has an equation of x squared plus y squared equals 49. A and B, A is on the x-axis, B is on the y-axis. State the coordinates of A and B. So at A, y equals 0. So if I substitute y equals 0, I end up with x squared plus 0 squared equals 49. So x squared equals 49. So x equals plus or minus 7. Now because A is on the positive end of the x-axis, x equals positive 7. So the coordinate then is going to be 7, 0. Now at B, here x equals 0. So if I substitute x equals 0 into that, I end up with, let's just write that down. So I end up with 0 squared plus y squared equals 49. So y squared equals 49. So y equals plus or minus 7. Now because B is above the x-axis, I want the positive value of y. So it's going to be 7. So then the coordinate then is going to be 0, 7. It then says that M is the midpoint of AB. Give the equation of the straight line passing through O and M. So here, if I just draw a line which should be straight from AB, this is M. Now I need to work out what this line here is going to be. So let me just do that in a different color. So I want the equation of that red line. So the first thing I need to do is first of all work out the gradient of AB. So the gradient of AB, well, it's 7 by 7. So it's going to be -1 because it's going down. So that's going to be -1. So therefore, the gradient of OM, which is perpendicular, is going to be -1 over the gradient of AB, which is -1, which gives me an answer of just 1. Now I know that the line goes through the origin. So I know it's the y-intercept, so M equals 1. C equals 0, so substituting the coordinates into y equals mx plus c, I end up with y equals x. Moving on to question 5, it says that a circle has its centre at the origin and has the equation of x squared plus y squared equals 81. And the question is asking us to work out the size of the radius. So again, all you want to do is remember that the equation of a circle with a centre at the origin is x squared plus y squared equals r squared. So r squared must equal 81. So r equals the square root of 81, which again is going to equal 9. Now you don't need to write plus or minus again, simply because you can't the radius can't be a negative length. Moving on to question 6, it says that a circle has a centre at the origin and a radius of 5. What is its equation? So here again, using the format of x squared plus y squared equals r squared, I'm going to substitute r equals 5. So I've got x squared plus y squared equals 5 squared. And I'm just going to expand the 5 squared. So I've got x squared plus y squared equals 25. And there is my equation. Now, I would say I would give full marks if I wrote x squared plus y squared equals 5 squared. But again, sometimes they do prefer it if your radius is not squared. Moving on to question 7, it says write down the equation of the circles. And so here, all we're doing here, now the centre is at the origin. So for this, it's going to be x squared plus y squared, x squared plus y squared, x squared plus y squared. And here, the radius r equals, or r squared, is going to be 3 over 2 squared. So let's substitute that in. So I've got x squared plus y squared equals 3 over 2 squared, which then if I simplify the r squared, I get x squared plus y squared equals 3 squared is 9, 2 squared is 4. Moving on to this next one. So here the radius is a half. So I've got x squared plus y squared equals a half squared. And then simplifying the radius squared, I get x squared plus y squared equals 1 squared is 1, 2 squared is 4. Then moving on to the third one. So here r equals root 3. So I've got x squared plus y squared equals the root 3 squared, in which the root and the square cancel each other out. So I'm just left with x squared plus y squared equals 3. Moving on to question 8, it says give the equation of the circle drawn on the grid. So as you can see here that the centre is 0, 0. So that means it's going to be x squared plus y squared. And the radius is 5. So therefore r squared equals 25. So in the equation of the circle is going to equal x squared plus y squared equals 25. Moving on to question 9, it says by drawing the graph of x squared plus y squared equals 4 and the line of x plus y equals 2, solve the equations for x squared plus y squared equals 4 and x plus y equals 2. So for this, now here I've already pre-drawn the circle. So I'm drawing a circle with radius of 4 with a centre at the origin. So the next thing for me then to do is to draw a straight line of x plus y equals 2. So for this, let me just draw a line. So here again, I would typically use a table of values, but generally when x is 2, y is 0, and when x is 0, y is going to equal 2. So it should look something like this. Now for this, what it then says is solve the equation. So when x equals 0, y equals, so for this is just to help you plot the equation for this. So this is going to be 2, and when x equals 0, 2, y equals 0 to draw the same line. So for this, all we then need to do is find the coordinates of where they meet, and they meet at x equals, and it's going to be minus 1.8, and y equals 3.4, and the second intersection point is here, which is 3.6, and y equals, that y ordinate, I make it out to be around about minus 1.6. And there we go. So this bit here is just to help plot x plus y equals 2. Moving on to question 10, it says how many times does the line y equals minus 6 intersect with the circle of x squared plus y squared equals 6? So for this, if I imagine that I'm about to draw a circle, so here is my circle, and let's just quickly draw a set of axes through the center, like so. This is going to be 6, this is minus 6, this is 6, this is minus 6, this is the y-axis, this is the x-axis. Now I then want to plot or sketch y equals minus 6. So y equals minus 6 is a horizontal line that looks like this. So how many times does it intersect with the line? Well, basically it's going to be once, and then says hence use a single word to describe what line is to the circle. Well, it's going to be the tangent. Then moving on to question 11. Now question 11 I would say is going to be quite a difficult question in terms of a challenge that typically you would get on a GCSE paper. Now this one does include using, I would say, a lot more coordinate geometry of looking at gradients, looking at surds, and just general higher level maths in terms of working this out, in terms of incorporating other topics in maths rather. So it says C is the circle with the equation of x squared plus y squared equals 1. Q has the coordinate of a half root 3 over 2 and is a point on the circle. The equation of the tangent at 2C at point Q can be written in the form of y equals ax plus b. Find the values of a and b. So let's have a look at sketching what this looks like. So again, what we've got is I've got a circle, and if I draw a set of axes, fit that circle there, go back to this. So here, this point here is going to be 1, this point here is going to be 1, that's minus 1, and this is minus 1, and this is my y-axis, and this is my x-axis. Now at a half, which is there, so this is where point Q is. And what I'm wanting is, I'm wanting a line. Let me just get rid of that blue bit there. Let me draw the line a little bit more accurately. So I'm wanting a line that passes through Q and the origin. I'm wanting the equation of that line. And let me get rid of all of that. So from this, we can see that this coordinate here, let's get a different color. So this point here is Q, and that has a coordinate of a half root 3 over 2. Now to find the equation of this green line, and let me just change that into a different color. It stands out a little bit. There we go. So I need to first of all work out the gradient of the line. Now let me just call this O here. So the gradient of OQ is going to equal, now the two coordinates are going to be 0, 0, which is the coordinate for O, and Q has got a gradient, or well, a coordinate of a half root 3 over 2. Now if I kind of just draw that right angle triangle to work out what the gradient is, well, the height is going to be the y ordinate, which is root 3 over 2, and this distance here is going to be a half. So the gradient of that line is therefore going to be root 3 over 2 divided by a half. Now that's root 3 over 2. And I'm going to imagine this is on a non-calculator paper. So then that then becomes root 3 over 2 times 2 over 1. The 2's cancel, so I'm just left with root 3. So the gradient of Q is going to be, of OQ is going to be root 3. Now for this, it's asking me to work out the equation of the tangent. So at that particular point, actually it's not that blue line I need to work out, it's going to be the tangent. So let me just draw a tangent like so. So this is the equation of the tangent. So the gradient of the blue line is root 3. So that means then that the gradient of the tangent is going to be the negative reciprocal because it's perpendicular. So it's going to be minus 1 over root 3. And this is my A value. So the next thing I then need to do is to find what this point here is. So then what I'm then going to do is using y minus y1 equals mx minus x1. I'm now going to work out what the y-intercept is going to be. So know that m equals minus 1 over root 3. And I know that the x1 is a half and y1 is root 3 over 2. So from this, what I can then do is substitute those three numbers in. So I get y minus root 3 over 2 equals minus 1 over root 3 x minus a half. Now it might look really complicated, but again, this is high level maths. So from this, if I then expand the brackets, so I get minus y minus root 3 over 2 equals, and then minus 1 over root 3 x minus plus 1 times 1 is 1 over 2 root 3. So then all I've then got to do is write y equals minus 1 over root 3 x plus, and it's going to be 1 over 2 root 3 plus 1 over root 3 over 2, because I'm going to take this over to the other side. So the next thing for me then to do is to then simplify that. So if I just scroll down a little bit, so let's just neaten all of this up. So again, because I've imagine this is non-calculator, so I need to have a common denominator. So that's going to be 1 over 2 root 3 plus, now if I multiply this whole fraction by root 3 over root 3, then I end up with root 9 at the top and 2 root 3. Now root 9 is just 3, so then what I've got is 1 plus 3, which is 4. So y equals minus 1 over root 3 x plus 4 over 2 root 3, and the 4 and the 2 cancel out. So I'm left with y equals 1 over root 3 x plus 2 over root 3, which therefore means that a equals minus 1 over root 3 and b equals 2 over root 3. Now moving on to question 12, it says the equation of a circle C is x squared plus y squared equals 25. The circle C is translated by the vector 3, 0 to give circle D. And the question is asking us to give the coordinates of the centre and the points of intersection of the x-axis. So looking at this, if I start by doing a little sketch of what that looks like. Hope this fits. It does. And what I'm going to do is with this circle is, let me just give it a different color. So I'm going to move this circle 3 squares or 3 spaces to the right, and that's moving it along the translation of that. So these coordinates here with the radius of being 5, so that's 5, that's minus 5, that's minus 5, and that's 5. Now we're shifting it 3 squares to the right. So then that's then going to be -2. That's then going to be 8. This is still going to be 5. And that's still going to be -5. And the center is now going to be at 3, 0. So here the center then is at 3, 0. Now where does it cross the x-axis? Well, I'm looking for this coordinate here, which is 8, 0. And this coordinate here is going to be -2, 0. And there are my final answers.